Welcome to another tutorial in MATLAB. In this tutorial series, we are looking into the concept related to Simulink. In this particular video, we are looking into the concept related to lookup tables. The first question is what is a lookup table? So lookup table is a kind of table which can be used to predict something or to map something. Um, like you have some input, you will be mapping it to some output. You can represent the same thing with the help of a graph. So whatever the value that you give inside the x-axis, that maps to a corresponding value in the y-axis. That is how you give the input and you get the output from the lookup table. So coming to the type of lookup table that we have in MATLAB, there are multiple dimensions based on which you can have lookup table. You can have 1D lookup table which receives only one input, have only one output for this, and based on the dimensionality increase, if you increase the dimension, then you will get 2D lookup table where you will have two inputs. You will get one out in this particular type of lookup table. There could be higher dimensions also, like 3D lookup table, 4D lookup table. So it is somehow similar to 2D lookup table. We will see all these things in detail. So coming to the 1D lookup table now. So we have suppose given input as 1, then we will get output as, if we are giving an input of 1.5, then in that case we will get a value in between 10 and 20. And if we give the value of 2, then we will get 20. If we are giving the value of 3, then we will get 30. And likewise it will continue. And suppose if we are going to give a value more than 4, could be 5, based on the patterns that is there here, the extrapolation will happen and maybe you will get some value greater than 40. So you will get a value greater than 40, and that is called extrapolation. And if you are trying to predict something which is beyond the range, like highest value, then it is called extrapolation. You are just extrapolating the line like this, and you are trying to determine that based on the pattern that is present here. If you want to determine a point in between, like you want to determine the point in between 20 and 30, then in that case it will be called interpolation. So there are two methods or algorithms that are there present for lookup table. One of which is called interpolation and another is called extrapolation. So if you see the lookup table, you will have one section called algorithms. So there you will find these two part which is extrapolation and interpolation. So extrapolation basically predicts the point outside the range, like this one. Interpolation predicts the range, like predicts the value within the defined like 2 points. Now coming to the 2D lookup table, if we see over here, so if we see the 1D lookup table, then in that case it creates a line which varies based on the pattern, and it will try to fit this line into this pattern, and then you get the output by giving the input. But in case of 2D lookup table, it creates a surface, as you already know, like we are in a 3-dimensional plane. So here it will be, suppose your y-axis and suppose this is your x-axis. Then in this case you need to give two inputs. So that is what happening here, and you have two inputs. This is the first one, this is the second one, and with that you are getting one output. So how this one output appears? So you have a point on y-axis and you have a point on x-axis, and that corresponds to a point on the z-axis. So based on this, you are getting a value which is the output value, And in case of the 1D lookup table, y axis was the output, here z axis is the output. Coming to the real applications, like how a lookup table is being used. So suppose you conducted an experiment by giving some input and output, and based on that you collected all the data that is related to the input and output relation. Right, suppose if you have two inputs, input 1 and input 2, then in that case you collect these two inputs, along with that you collect the output also. So with this data you will be able to create a lookup table which you can implement and see how the lookup table is behaving or how the system is behaving, and based on that you can try to replicate the experiment, and that will help you to reduce the complexity also. So we will see that in the advantages part, like what are the advantages that are there by using a lookup table. So if you come to the interpolation and extrapolation, so here you will have for extrapolation two algorithms. One is linear and one is cubic spline. Those things we will discuss in detail in the coming video. And the another is the interpolation, and here you will have around 5 algorithms: flat, nearest neighbor search, and linear point, and linear Lagrange, and cubic spline. So these are the algorithms that are being used based on the use cases and based on the complexity. So it will run and it will try to predict the points and align it properly to get the output. So coming to the advantages, so what are the advantages that we will get from here? As it is a table, so it contains only this much amount of data that we have, so it improves the speed of the system to give the response, because you already give the input, and like both the inputs if you give here, you are getting the output at this like maybe next sample time. So the calculations are very in this particular lookup table, whereas if you try to do this by implementing an algorithm, then that algorithm will be complex based on the mathematical calculation. Based on that like you can convert the input and output mapping if possible into a lookup table, and that's how you reduce the response time and improve the speed of the system as much as possible. If you use lookup tables in your models, then it will improve your performance, and also it will improve the speed of calculation. Along with that, it reduces the complexity which we discussed. Like suppose if you have a entire for example, for this particular system, if you have inputs given and you try to map it using a neural network or algorithms, then the complexity will be very high. So here what you have data, and that is mapped to a table, and the complexity is significantly low, and the computational power in this case is very low, as we already discussed. And this is a simple algorithm to implement. Simplified algorithms are there already inbuilt. You just need to give the data, and the calculations are also very simple. So you can also recreate in pen and paper the calculation, so that it will not like you will not get confused with the simulation. And it also ensures consistency. So suppose if you conducted this experiment, whatever the value, like suppose if you have given 2 over here in the first input and 20 over here, then you will always get 200. So the consistency will be there. You will get a detailed good performance based on whatever you are designing. So there are many advantages that you will have on implementing a lookup table. So basically the concept related to the lookup table is also important, why we use it, and why it is needed, and why it is actually being used in models. Yeah, this is all about the lookup table for 2D and 1D. And yeah, in case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. It will be a lot help to us to improve your experience of learning MATLAB in this channel. Have a great day ahead. Thank you.